So, two more things left. The normal quantiles and how to find the mean and standard deviation when given probability. Basically reversing what you normally do in the calculator. Normally you will have your mean and standard deviation, and you'll be able to use that to find certain proportion or probabilities. Am I making sense? So take for example, you are guaranteed that the distribution is approximately normal. You are guaranteed the mean, and you are guaranteed the standard deviation, so you know the spread. With this information, you are able to know, everything is 1. So halfway is area 0.5, probability 0.5. These are your x values. With this, you'll be able to know what x value is corresponding. You'll be able to know the proportion or the probability that a certain value of x is less than or equal to maybe xi. Clearly, if your xi is above the mean, you expect the probability to be more than 0.5. And if your xj, for example, is below the mean, you expect the probability of the region that it occupies to be less than 0.5. Does that make sense? That's what you have done so far. You do this with the help of your mean and your standard deviation. Now, what we are trying to do today, which is the last thing we are trying to do, there are two things. I will explain both together, but you have to spend some time focusing on this today and Thursday, because it's definitely not happening. We finish everything. And Thursday, you practice the last aspect. There will be no teaching if applicable. Now, what we want to do at this point is, suppose, now this could be, for example, instead of xi, maybe my xi is 50. Maybe my mean is 30. The probability that, you can always get the probability that x is less than or equal to 50, then you consider the area of the region from here to here. If the question is about probability that x is greater than or equal to 50, you consider the remaining region. Am I making sense? But in this case, all these probabilities are less than or equal to 1. We all know that. But in this case, you do not know what these x values are. You are using probability to get the missing x values. So in the first case, you have your mean and standard deviation again. But in the second topic, the last topic, your mean and standard deviation will be missing, either one of them or both of them. So, using probability, with a given probability, you will be interested in some value k, such that the probability is probably maybe 0.8, which means in your normal curve, probability 0.8 means it is above the mean. Am I making sense? So you are looking for a value k such that the area under this curve is equal to 0. This value is what it's referred to as normal quantiles. Does that make sense? So basically, you can also relate it to percentile. So if your area, for example, is 0.8, you are saying that the value which represents the 80th percentile of the distribution, it means 80% of the entire distribution lies below the value. Am I making sense now? So that is why it's called normal quantile. So that value is the percentile. So in this case now, my k is the 80th percentile of this distribution. It is the same as being given probability that x is greater than or equal to k. No, this same thing is equal to 0.2. Agree? So in this case, you can't call it 20 percentile. The last 20% is not 20 percentile. Percentile simply means, if you remember your cumulative frequency curve, talk about percentile. If someone is referring to, my score is in the 60 percentile of the topic, it means 60% of the entire class got below your score. It's always with respect to, the minimum, the beginning. It may not be 0. This is a score. So the minimum score could be 50. Am I making sense now? So this is what this is about. That's why it is called normal quantiles. Just like fractile, like your percentile, decile, something like that. Okay? So that's the introduction I would like to give you on this. Now let's look at this, this illustration as well. Consider a population of crabs where the length of a shell x, so that is the random variable now, x millimeter is normally distributed with certain mean and standard deviation. A biologist wants to protect the population by allowing only the largest 5% of the crab to be harvested. You see, there is no specific length of what you could harvest. But we don't want you coming into the ocean every time and just pack the crabs and go, because in the next few years we may not even have any seafood anymore. So maybe there's a regulation. Anytime you are going for your fishing, you can only take 5% of the entire distribution. Do you understand that? Well, with the mean and standard deviation, if you say, oh, you can only take the top 5%, now with this information, look, only the largest 5%, right? So in this case now, you are saying that you can only harvest these ones. Am I making sense? Whereby this area is equal to 0.05. Which means we're interested in the value of K, which serves as the 95th percentile. Am I making sense? The value of K such that 95% of the entire length lies below that value. That's the meaning of only 5%, top 5% to be harvested. If you are in your top 2% in your class, Brandy, then your score is what percentile? 98 percentile. So you need to be able to distinguish between these two information. If you are in your top 7% of the class, then your score must have been what percentile? Say that again? 90 what? Did I say top 3? I thought I said top 7, right?
Yeah.
What did I say? Top 7? Oh yeah, if you're in top 7, 93 percentile. Does that make sense? So if we are interested in only the top 5% of all the lengths, because we want the other length to grow, so you can only pick the top 5%. It means your minimum has to represent the 95th percentile. And this K is the quantile we are talking about. So let's look at how that can be done in the calculator. Bring out your calculator. You don't need to do any long calculation. You use your calculator. And I will advise you, you always draw the normal curve to illustrate what you are doing. Always. Okay? There's a calculator here if you want. So, okay, let me play the audio first. You might get one or two information there. I think it's just one example actually. Listen.
Earlier in the chapter, we saw how to find an interval for a measurement within a normally distributed population, given a probability. The number k is called a quantile. Earlier, we only did this when k corresponded to a whole number of standard deviations from the mean. We now consider quantiles more generally. Finding quantiles is the reverse of finding probabilities, so we do this using the inverse normal function on our calculator. In this example, the shell length of a population of crabs is a normally distributed variable x, with mean 70 mm and standard deviation 10 mm. We seek the quantile k such that the probability that x is less than k is 0.95. This means that 95% of the population have shell lengths less than k. The probability is the value for area that we need to give in the inverse normal function on our calculator. We also give the mean and standard deviation, and find that k is approximately 86.45. So, the 95% quantile corresponds to a shell length of 86.45 mm. Note that on some calculator models, we must always use the area to the left of k. So, if we wanted to find k, given the probability that x is greater than k was 0.05, we would instead calculate k such that the probability of x being less than k was 0.95.
Does this make sense? So forget about the calculator, whatever mode, let's focus on our calculator. So I will advise you, and I will watch out for that if I'm giving you a test or mock or whatever, you need to illustrate what you are doing with a normal curve. It helps, and if you run into some trouble, this could fetch you 1 or 2 points, even if your calculation is wrong. Okay, and it helps you also to visualize stuff. So this is how, let's try this. You are interested in the value k such that x less than or equal to k is 0.95. I will explain the tail in a bit. You don't have a calculator? You've done it. Nice. So basically, this is the picture. So I'll show you something now. Okay, maybe I put it here. So what you have done with your mean of, what is the mean? 70. And your standard deviation is 10. So it means the next one is 80, before it is 60, right? We may not need all this. So 95%, so your k is here, such that the entire area here is 0.95. Understand? Can you change, have you done this, everyone?
Yeah.
Can you change this to the tail to right? Change the tail to right. Leave every other thing constant. What do you get?
53.
Say that again?
53.55.
But in the first case, k is what? K1 is 80,
6.45.
86.5. The second k is what?
53.
Now, this is what you have done for the second case. Okay, maybe I draw a new picture. When you say tail left, this is what they mean by that. The shaded part is on the left. Understand? Tail right means the shaded part is on the right. Okay? Now, by telling you to keep everything constant and only change the tail, what you are saying is that towards the right side, you have 95% of the entire population. So, if I have the entire population at 5% on this side, basically I have only 5% on the left. Am I making sense? So that is why you have gotten 50 what again?
53.
53 points.
55.
So you could see that it's lower than the mean. Am I making sense now? Now let's do something. Let's change this area to the 5%, 0.05. Leave it as tail right. See if it's equal to K1. Is it the same?
Yeah.
So if you change this back to left, what is the one? What is this one? Tail right now. Okay? Tail right instead of the, what did you do before? 95%, right? So tail right.
We did tail left and 95%.
Tail left and 95%, which is this one. That's the first case. It will be, and we have just checked, it's same as tail right 5%. In this case, we did tail left what before?
No, we did tail right and 95%.
Okay, let's do this. For this one, your tail right 95% should be the same as tail left 5%. Agree?
Yeah.
Check that. Did you get that?
Yeah.
So this is why the picture is very important. Because if you do not understand what you're putting in the calculator, it's just a waste of time. Okay? Now, another thing, if you check the other option of tail, what other option do you have there? Central. Is it central or center? I don't know. Okay, central. What that means is that you have it in between. Does that make sense? Maybe we are looking for some value k such that, this is your mean, right? Okay? You are looking for some value k such that that value is 15 or 10. Okay, in this case, what is our, let's look at this. It is 70, right? Let's pick a number, say 8. 8 on both sides. So I'm looking for, that number would have been 70 what? 78 and 62. Am I making sense? So the value k is such that k minus, okay, check. With your normal probability, can you check the area under that lies between this? With your mean of 70 and standard deviation of 10. If the mean is 70 and standard deviation is 10, find the probability that x lies between 68 and 70, based on what we did before. Understand? So you put your limits. So Nakita got 50 what? Talk to me, please.
0.576.
0.576. That's the probability. Now, let's pretend we don't know that. We want to now figure out the value of k that gives you that spread. Am I making sense? So let's use today's lesson to figure out k. So k is the gap. In this case, we use k as 8, right? So let's now figure out k such that probability that mu minus k, which is your mean, less than x, less than mu plus k, gives us 0.576. Do you understand? This is what we want to do now. What this means is that you will do the central, change this to central, change that to central, then your total area is 0.576, then leave every other thing constant, tell me what you get. Every other thing means your mean, your standard deviation, all that, all right? What do you get? 2 values.
Yes.
So you got x1 is equal to?
62.
62.
0.0.
Okay, so let's say 62. x2 is equal to? 70. 77 point. So let's say 78. So if you get that, you will then say, oh, it means my mu minus k has to be 62. Which means my k is mu minus 62. Your mu is 70. So automatically your k is 8. Of course, I wouldn't write mu here. I would write 70 minus and 70 plus. If you don't use x1, you can use x2. Using x2 now, it means your 70 minus the same k is 78, according to your calculator. So you get k is equal to 70, wait. Oh, plus, sorry. Plus 70 plus k, not 70 minus k. Then my k is equal to 78 minus 70. Again, you get your 8. You don't need to do both. You use either of the x1 and x2. Those x1 and x2 are your lower and upper limits when I ask you to find the probability here. Do you understand? So it has just been given back to you in reverse form. Am I making sense, please? So this is how we do the reverse by using this to find the quantiles. Okay? And this is what I have put in the first worksheet. Let me quickly, because of our time, I'll give you time to practice this. So I put all these questions in your worksheet and I put a space for you. But let me quickly explain this. So for today, after the explanation, you focus on these 10 questions, which is the worksheet I've given to you. I will hand out the other one, so if you have time before Thursday, you are welcome to look at it. So from Thursday, I'll be printing past question. That's what we're going to be doing henceforth. Then from there, we can remind ourselves of stuff, and we fix certain dates for maybe a general test or whatever. Is that understood? So, how do we use what we have learned so far to find unknown mean and standard deviation? If you check past question, this also comes out a lot. This also comes out a lot in your normal distribution. And it's easy. You're not expected to do so many calculations. Picture, calculator, explain. How do you explain? By showing some of these details, by writing in this notation, so we know what you're doing. You're communicating appropriately, using the right symbols. Understand? No one expects you to do integral of f of x. No, that's not for this level. That's what I went through in my time, not what you have to go through according to the syllabus. Technology is expected. Now, z-score is your way out when trying to find your mean and standard deviation. You might be wondering why. We had already talked about, during the z-score lesson, we said what you have originally is your x-score. So we have our x1, x2, x3, then your mean. So your mean is one of the x's. Am I making sense now? And the gap between your mean and the next x is your standard deviation automatically, isn't it? Then we're able to change all these x scores to z scores. So that the mean is what? 0. And there's a gap of 1. So you have 1, 2, 3. So this is -1, -2, -3, and so on. This idea, because it represents the same distribution. And the last note I brought to your class, I said if x1 is less than x2, remember? It means your z1 is also expected to be less than z2. That is trivia based on the fact that your mu in the transformation, z is equal to what? Quickly. In the transformation, z is equal to what? X minus mu divided by sigma. Okay? These two are constants. The bigger this is, the bigger the z. So that is why we can conclude that this happens if and only if this happens. And that's why all their probabilities also follow the same direction. Am I making sense? So let's see how that can help us in this regard. Okay, listen to this, then I can add more explanation later. I think this is the only example.
In the last example, we used the inverse normal function on our calculator to find quantiles of a population with known mean and standard deviation. When one of the mean or standard deviation is unknown, we cannot use this function directly. However, given a quantile, we can use z-scores and the inverse normal function to find the unknown mean or unknown standard deviation of a normal distribution. In this example, we are given the standard deviation of the normally distributed weights of a scallop population. We need to find the mean weight of the population. We let the weight of a scallop be x grams and the mean weight be mu grams. We are given the 15% quantile for the population is 58.2 grams. So the probability that x is less than or equal to 58.2 is 0.15. Since we do not know mu, we cannot use the inverse normal function directly. Instead, we consider the z-score, which has the same quantile in the standard normal distribution. The area to the left of the quantile is 0.15, the mean is 0, and the standard deviation is 1. The corresponding z-score is about minus 1.0364. We can now rearrange the equation to solve for the mean mu. The mean weight is approximately 64.3 grams.
Understand? From what I said here, it doesn't matter whether you say when x is equal to xi or when x is equal to 2, if your xi corresponds to 2 when converted to the z-score. It doesn't matter whether you say probability that x is less than or equal to xi is equal to maybe 80%, which is talking about this, or probability that z is less than or equal to 2 is equal to 80%. It doesn't matter. What you are saying is that area under this curve is 80%. Whether you are speaking in Chinese or you are speaking in English, you're talking about the same thing. Because it's been converted to be equivalent. And that is what the z-score does. So that is why the idea of z-score was used. Okay? If this is this, then the corresponding z-score gives you that. The same thing. So the z-score corresponding to 58.2 is just going to be 58.2 minus that, and that is where your mean is revealed. What you do if both mean and standard deviation are missing is that this probability will be given twice. When that is given twice, you are going to form equation twice. Mean and standard deviation will be missing, so this will be unknown, this will be unknown. So you will do this twice and end up with this equation in terms of mean and standard deviation, and you solve simultaneously. That's all. Does that make sense? And of course, there might be additional question after this. After you find your mean, the next question might be, what is the probability that maybe in this case now is about what? Population, something population, right? Okay, the probability that maybe a certain population is greater than or equal to something, which normally you need your mean and standard deviation to do in the calculator. But the mean and standard deviation was missing, you have figured that out, then you can use it for the next questions. All in the calculator. Just make sure you write things down. Show this kind of workings as well. If you have mean and standard, I don't know if there's an example on that. Oh, there is. Listen to this. Listen to it. Easy as well. Very easy. I think this is the last example. After this, I'll leave you alone. Come on, load fast, okay. So I can leave them alone.
In the previous example, we found the unknown mean given a quantile and the standard deviation of a normal distribution. In this example, both the mean and the standard deviation of a normally distributed random variable x are unknown, but we are given two quantiles. We illustrate these quantiles on a normal distribution curve. Since we do not know the mean and standard deviation, we start by finding the z-scores corresponding to the x values 20 and 29. We are told the probability that x is less than or equal to 20 is 0.1. We convert the x value to a z-score, then use the inverse normal function on our calculator. The corresponding z-score is about minus 1.282. We are also told the probability that x is greater than or equal to 29 is 0.15. Since many calculators only consider areas to the left of a quantile, we will convert to the equivalent form. The probability that x is less than or equal to 29 is 0.85. We convert the x value to a z-score, then use the inverse normal function on our calculator. The corresponding z-score is about minus 1.036. If we multiply both our equations by the standard deviation sigma, we now have two linear equations involving mu and sigma that we can solve simultaneously. We can do this by technology or by elimination. We find that the mean mu is about 25.0. and the standard deviation sigma is about 3.88.
Understand? Don't forget that the inverse calculator was, calculating this inverse was focusing on the z-score for a purpose. We have no idea about the mean, but we know that for z-score, the mean and standard deviation are known, so it is easier to be done. Do you understand? For the z-score, remember, if you are finding inverse like this, where did we find inverse today? Here. Remember when we did this, you supply the mean, standard deviation, then you are looking for K such that this percentage happens. In this case, we are looking for the mean and standard deviation of X scores. But when you change it to Z score, it is easy for you to apply this because the mean and standard deviation of the Z score is known, regardless of what the X score looks like. 0 and 1, constant. So you use your Z score to perform this inverse so as to know what is that value in Z.